check one. 우리 인민아. check one. check one.
Okay. Okay, welcome everyone. Hello, testing. Okay, can you hear me? No? Hello, testing 1, 2, 3. Testing 1, 2, 3. No. Can you hear me? Or do I need to speak louder? Let's see. Volume effects. Volume. Hello, testing 1, 2, 3. Okay, good. Welcome to this morning's, or rather, it's actually 3 sessions, starting with the one this morning. So this is network engineering workshop for the whole day. We have about we have 5 topics to share this morning by 5 speakers. So it's 1.5 hours. So each speaker probably about 15 minutes and about 3 minutes for Q&A. I think roughly around there, and that will give you 18 minutes times 5. You give you 1.5 hours. Okay, so that's roughly the timing. So maybe just to start off, I'm John, and I'm part of the Stingerand team. And yeah, so good to see all of you here this morning. The first speaker for this morning, Brenna Meda. So she'll be sharing on GNA APAN International Routing Working Group. So the synopsis of this would be the joint APAN GNA Routing Working Group was formed to address global routing issues impacting performance of international data flows. The group has addressed many routing issues, including asymmetric routing, inefficient global routing, flows using commodity routes instead of an R&E path, and changes to links impacting traffic throughput throughout the world. I think it's very interesting. Brenna was just sharing about certain routes that goes out of the country and comes back into the country, and such inefficient routes actually can be optimized in good ways. So let me invite Brenna up. Thanks.
check one.
No. Yes. Okay. Oh, good. Good morning, everyone. My name is Brenna Mead. Please hold. Okay. Don't touch it. Okay. Hi, everyone. My name is Brenna Mead. I work for International Networks I didn't even touch it that time. I work for International Networks at Indiana University. Okay. Sorry, I'm a little flustered now. So some of you went to my session yesterday. This will be a shorter version of that session that I gave yesterday, just a brief synopsis of what I talked about yesterday. Yesterday, we went over all the cases that we're working on. We won't be doing that today. It's just going to be a general overview. For any of you that have questions or want additional information, feel free to find me at any of the receptions or around the area throughout the day, and I can help answer any questions that you may not have gotten out of this presentation. Let me just try one thing before I try this side. Okay, we'll see. So as the synopsis that was just given says, the International Routing Working Group has been around for about 2 years now. It was established to create a community where we could look at addressing global routing issues, such as those that were mentioned, and I will go into those in a little bit. So the goal is really to engage network owners and NRENs from all around the world in order to proactively address routing issues versus reacting to them as they come to us. Many of us know that network engineers and people in our community are usually reacting to a problem, and they are not proactively trying to solve problems before a researcher complains or they see a performance issue. This is because network engineers are busy. They have their day job to do and to react to each and every day. Being proactive about these types of problems is challenging. So I'm the co-chair along with Warwick Mischel from ARNet and Hans Adelman from Indiana University. We have two goals. One is an engineering focus, which means network engineers working to document possibly erroneous routes or anomalies that we may see within the RNE community. And then once we've done that, we identify teams within the engineering group to work on those cases. And then each meeting, we have meetings monthly, the third Tuesday of every month. And in those meetings, we check in with each other about how far we've gotten on the case, what the next steps are, and what any roadblocks are to solving those cases. I apologize for this. It's making it difficult to see. The second goal is policy focused. So the ultimate goal is to create policies for all of us as network engineers to use, to follow, including preferred backup plans and then or paths, and then also to verify that the policies that we're creating within this group are actually being followed throughout the NREN community. So no, it's okay. We'll survive. I'm a survivor, as the Destiny's Child song goes. So traditionally, to discover these routes, I've been using a tool called NetSage. All of the APONet members of this community, so many of the people in this room are members of APONet, and APONet contributes SNMP data to NetSage, and many institutions also submit flow data to NetSage, which allows us to use that tool to take a look at where traffic is flowing, how it's flowing, and the performance of that traffic. So using NetSage, it's easy to find data on rate and volume for data transfers going all around the world, specifically in this case, the APONet system. In addition to looking at performance, I can also give you clues as to how your traffic is being routed and others information. We also use trace routes. As network engineers, all of us are using trace routes and BGP. We also use route views, peerings, and router proxy looking glass to take a look at these, at how traffic is routed around the world. Okay. The introduction mentioned these, but I'm going to go over them again. Some of the challenges that we've observed as we've in the past 2 years with this group and previous to this group, asymmetrical routing, meaning that a source takes one path to a destination and a different path on the way back. As I said yesterday, asymmetrical routing isn't necessarily bad, but within the routing working group, as part of that policy focus, we would like to know why it's asymmetrical and make sure that that's the path that you as the engineers and as the NREN owners are expecting that traffic to take. Sorry, I do not have these slides memorized. RNA data that takes a less efficient route around the world, affecting performance. Some examples of this are Europe to Asia routes traversing the US. So when they should go Asia to Europe, instead they're going all the way around the world. That will have an impact on performance, not just round trip time, but also latency. Another example is Africa to Europe routes traversing the US. That also doesn't make sense because once again, traffic is going all around the world to, okay. Please hold. It's okay. We go with whatever occurs in life these days. Where was I? Sorry. So another issue that we observed is RNE data that takes a commodity route instead of an RNE path. For those of you that run NRUNs, you know this, but many members of the community do not know that commodity networks are not engineered for RNE traffic. They have different goals in terms of the services that they're providing. RNE networks are tuned for performance and tuned for large data transfers, whereas commodity networks have different goals, such as DDoS protection, and they don't necessarily care about the performance of your connection. They just care that the packets go from one destination to the next, whereas RNE cares both about whether your packets go from one destination to the next, but also whether they've performed efficiently and performed in the way that we expected them to. And then the final challenge we've observed is new RNE links are removed or added, but BGP and engineers are not adjusting the routes to appropriately use those links or stop using those links, depending on if they're new additions or removed RNE links. The routing working group has 170 members subscribed to the routing working group list. There's over 80 countries and over 30 institutions involved on the email list. We have a total of 17 solved cases and 1 case on hold due to, actually that number is incorrect. We have 21 now open cases, 17 solved cases, and 1 case open, or 1 case on hold due to lack of resources. As part of the routing working group, we do not just work on routing working group cases. That is our primary goal, but we also hold tool talks so that engineers that are involved within the working group can learn how to use some new tools that have either been around in the community for a very long time or are just appearing within the community for use. So we've had all of these tool talks, and all of these tool talks are available to the public on our website and at these links. So if you have any interest in taking a look at Manners or Router Proxy, watching Steve Wallace's Internet 2 Routing Integrity presentation, some more information on NetSage, or even looking at Professor On's developing a collaborative BGP routing and analyzing and diagnosing platform. We have all of those slides available on the website and here for you to take a look at. The reason we have these tool talks is not just to educate, but also to continue to create a community where we are on the cutting edge of understanding these tools, and we know how to use them, and we are using them effectively to solve problems and troubleshoot within the routing working group community. What have we learned in the last 2 years? The routing working group has created a number of new connections and resources within the NRUN community, especially for engineers like me that are new to the community. As I said, this routing working group has been running for 2 years. I've also been working at Indiana University for 2 years. So it's been an incredible opportunity for me and others that are new to the community to meet other engineers and collaborate and troubleshoot and find people you can trust and people within the community who are willing to work with you on troubleshooting and any other sort of coordination issues. We've discovered that the RNE community as a whole is eager to solve these issues and eager to work together. As you saw in the keynote, there's a very large focus in our community on collaboration and making sure that we are working together as NRENs and as a global NREN system to support each other and to collaborate and to make sure that we are all working together for the greater good and the good of our scientists and our researchers. We've also learned that there's, as we saw with the number of tool talks we've had, there's a wealth of tools and information that exists to optimize routing for science. There's even more that we haven't had come and do tool talks, and there's probably more that people are working on that we don't even know about. So if you know about a tool or you would like to share something that you're doing that you think could assist in the routing working group, or that would be interesting to this large number of R&E engineers that are part of this community, do let me know. We're always looking for more tool talks, and we're always looking to increase the amount of knowledge that we have within this community. Additionally, solving these issues is a truly global challenge because we all have distinct networks, we all have distinct policies, and finding a way to collaborate with all of these different institutions and with different policies and different goals, while also trying to align those with a general goal of supporting our science, supporting researchers, and supporting researchers on a global level is a distinct challenge, but something that I think all of us it's clear to all of us that we are working on, especially with the keynote that we saw yesterday. Well, the final thing is, I think we need, as a routing working group, we need continued engagement from some of the other organizations that are a part of the routing working group. Many of these cases that we find are just me looking at NetStage and me discovering problems as an engineer doing my day job. We've had a few cases come from the rest of the community, but we're hoping for more engagement from some of these other NRENs and other network owners to help us find more cases or help us determine what the next iteration of the routing working group is over the next 2 to 5 years, as we continue to hold these meetings and continue to try to work as a community to solve these problems. Upcoming meetings, so we do try to do an in-person meeting occasionally. Our meetings are virtual. We try to accommodate both Europe and Asia, so they are in the morning in the US, and then in night in the US. The morning tends to accommodate Europe, and then the evening meetings tend to accommodate our Asian collaborators. So they rotate every other month as to what time they'll be. We do have an in-person meeting coming up at TechX 23, which is in Minneapolis in the United States. At that meeting, our formal goal for that meeting will be to talk about next steps, what we want to do over the next 2 years, and like I said, how we can start to engage more participation and more NRENs to do this type of work and see what our next goals should be. No meetings in November or December, as many of the members of the routing working group, as am I, are working on SC in the United States to facilitate demonstrations and work on that network during that time. So it's actually very shocking how many members of the routing working group have some sort of involvement in SC this year. So we will not be having a meeting in November or December. So this is my call out. We would love for you to join the routing working group. We would love for you to submit your cases or come and do a tool talk. We have a mailing list, a Slack channel, and a website. Those are our emails there if you're interested in joining the routing working group. Feel free to come up to me and ask any questions that you may have. We're always looking for new members and specifically tool talks. So thank you all for your time. If you all have any questions, feel free to ask them now or find me in many of the social events. I will be around until Friday. Thank you also for tolerating our IT issues. Just a moment, we need a mic.
So where can I find the cases you just talked? Can I find it in the website?
Yes, so they're not on the website, but they are in the slide deck that I have for the other presentation that I did yesterday. So I'm going to send the slide deck out to the routing working group list, and you are on that list. So I will, in that slide deck, we have a list of all the cases and all the documentation for those cases. So I will send out the recording for this session and yesterday's session, plus the slides to the routing working group, so you can get them that way. That might be a good suggestion. I could put them on the website. They are not, the information isn't to access that is not currently on the website, but that is good feedback. Maybe I can put that on the website for others that may be interested.
Okay, thank you.
Do you have any guidelines for the network engineers with regard to doing filtering, or maybe not just filtering, about redistributing the routes that they receive from maybe their peers, the other NRANs, because this may be the origin of a lot of the problems.
So we are working on, that is one of the deliverables we are hoping to come out with in the next 2 years, is some guidelines, some procedures, some sort of how-tos on how to find some of these issues, and then what we did to solve them. So that is in our next iteration. That is one of the goals for the next iteration, along with potentially best practices for routing configurations, BGP configurations. And we also are looking at having some engineers come and discuss their network configurations and how they're solving specific problems that they're seeing within the R&E community through the tool talks. So that is, so the first 2 years we wanted to make sure that this problem existed and that we could solve the problem and that we could work as a community. And I think the next steps are working as a community to document what we've seen and create some best practices and some procedural documents for engineers wanting to use those documents and use those resources.
Yeah, thanks, Brenda. Yeah, we all acknowledge that routing is so important, not just on normal day, but even when links go down and all that. Okay, so next we have update, a SINET update, the new EU JP connection and DDoS mitigation services. So this will be by Osamu Akashi or Kitagawa. So SINET is a Japanese academic network dedicated to enhancing R&E networks activities at the universities and research institutes. SINET 6 began operations in April 2022. And new technologies and services have been continuously introduced for improvement. So this presentation will focus on the new EU JP connection, which will start operations in April 2024. And together with that, they are putting in place a DDoS mitigating service, which will be applied to the SINET connected organizations. Okay, invite.
Yep.
Takashi.
Yeah, sorry for introduction. Let me share the screen.
Okay, thanks, Takashi.
Yep. Can you see it?
Yes, you can see. Thanks.
Yep. Presentation mode. Okay. Thank you. This presentation is a SINET update, including new EU JP connection and DDoS mitigation service. And the first one, I will explain about it. And the second one is explained by Kitagawa-san. First, sorry for remote presentations. Okay. First one is a brief introduction of SINET. SINET is a Japanese academic networks connecting the Japanese university and large experimental facilities. Currently, we are connecting to more than 1,000 organizations. This is a SINET 6 transition. SINET 6 started from 2022, and its features are nationwide 400 gig lines, 5G mobile capabilities, and secure and flexible services by NFV and routers, and international lines enforcement. So this shows a domestic 400 gig line topologies. As mentioned, we are connecting more than 1,000 organizations and also connect to the Singapore, Guam, and Los Angeles. So this table shows the connection status of SciNet organizations, SciNet customer organizations. Compared with the SciNet 5, SciNet 6 average speed is 15.1 gigabps. So we can observe the three times up over increment in the access lines. So this is the old SciNet 5 topology. As you know, SciNet connect Tokyo and Singapore, and similarly, Tokyo, Los Angeles, New York, Amsterdam, and similarly, Tokyo and Amsterdam. It will be connected using the 100 gig lines. So this is the SciNet 6 topology. We added the new line between Tokyo and Guam and increased the bandwidth between Tokyo and Los Angeles and Los Angeles, New York from 100 gig to 200 gigs. So as you know, this Tokyo Amsterdam EUJP lines are traversing the Trans-Siberian areas. So we have just finished the procurement. So we have two options. One is using the Trans-Asian areas, and one is traversing the United States areas. So current Trans-Siberian lines RTT is 115, and if we use the Asia area, RTT is about 280, and if we use the US areas, RTT is about 240. So we chose the line traversing the United States area, and we will connect the Tokyo and Amsterdam without a new intermediate routers. Expected RTT is 223. So this is an update from the April 2024. So we are also collaborating with other NLENT, such as APAN, AER, and ANA. So from the viewpoint of the AER, this Tokyo and Amsterdam line will be increased from 400 gig lines. So we will, although the RTT is increasing, but we will upgrade the bandwidth from 100 to 400 gig lines. SciNet also develops a lot of services. So from the SciNet 6, we have developed the filter on demand, mirror on demand, or autonomous DDoS mitigations. So today's one more topic is about automatic DDoS mitigations. So please continue, 北川先生。Something problem?
Akashi-san, can you hear us?
Yeah.
Okay, sorry, our internet connectivity went down for the whole place.
Okay.
Yep. Okay, so do you want to share your slides and Not too sure where you dropped off, so let's catch up from there.
Yaga-sensei, can you hear me?
Yes, I hear.
Ah,
You
so-
finished that.
Yeah,
So,
okay. Please continue. Sorry for my
but we
disruption.
had about the 3 minutes only.
Okay.
Share slides or?
Okay. What recognize, but
Yeah.
I think that we need to change the setting for the projector. No? Yes, right. Oh, sorry. Okay.
Can you put the other screen live?
So you できない。認識はしてるんですけど、はい。多分こっち側の設定の問題だと思う。 Okay. Okay. Okay, so I'll start the talking our DDoS mitigation service. I'm Naoya Kitagawa from the National Institute of Informatics. And first, I will introduce an overview of the service. And we launched a new service in January of this year to automatically detect and prevent DDoS attacks. The system deploys attack detection system within the SciNet, and we register IP addresses for attack detection based on service application for each SciNet connecting institution. And this system can detect the attacks in real time and alert administrators of each institution. In addition, we are currently developing a function to block DDoS attacks packets, which would allow packet filters to be automatically configured about 10 seconds after an attack is detected. And the two figures below shows a comparison between our conventional DDoS mitigation service and the new service. In conventional service, DDoS attacks must be detected by each institution, and next the operator submits a mitigation application to SciNet operation desk, and then SciNet operator configure the packet drop setting on the routers. And next, the right side, in the new mitigation service, at first, each institution applies in advance to use the service and registers the IP addresses to be monitored. This system collects information and performs attack detection and can automatically configure filter setting on the routers. And the system completes the process from attack detection to packet dropping configuration to the routers in about 10 seconds. And the system consists of 4 elements. At first, NTD is the main element of the system that performs DDoS attack detection on mirrored packets received from routers. And it is no direct manipulation of NTD in the system in operation. And NTD does not have GUI, and the status and its status is referenced via CMS. And the CMS is the central management system, and it is used to change attack detection threshold and change operation mode and manage system-wide alerts. And SWA provides GUI operation and information reference for this system and display the control status of the system and the traffic graphs and attack information. And it provides IP addresses registration for of the router to be controlled. And SSP is a user portal, and it creates tenants and tenant administrator accounts and browses graphs and attack information for all create tenants. And this figure shows the configuration of the test system created prior to starting this DDoS mitigation service. And to generate traffic simulating a DDoS attack, we prepared two servers, HPin1 and HPin2 here and here, and connected them to the routers. The HPin1 server generates and sends traffic, and the HPin2 server received it. And in addition to the traffic generated by the HPin routers, the actual traffic is also mirrored into the routers. And each of the components of this DDoS mitigation system, so the CMS and SWA and NTD, were implemented on virtual machines using KVM. And this figure on the focuses on the communication between the router and the DDoS mitigation system in the test environment. The RM1 router inputs mirror traffic from NII, which is the actual traffic at this XE0501, and also inputs dummy traffic from HPin1 at XE500. And the RM1 routers their inputs mirrors to XE520 for DDoS mitigation service. And between the DDoS mitigation system and each router, telemetry is used to exchange the communication status, and netconf is used to control the routers. And as explained earlier, our system has monitor mode and to monitor the attacks, and has mitigation mode to block the attacks. And this figure shows the processing flow in monitor mode. So when a SYN flat attacks was performed from HPin1 to HPin2, the DDoS mitigation system detected the attack in 15 to 20 seconds after the transmission started, and the system configured additional filter settings for the router using netconf. Of course, because now the system is in the monitor mode, so no packets are discarded when filter settings are set on the router, and the system gathers information. Then, the 5 minutes after the HPin1 stops the SYN flat attack, the system sends the filter release configuration to the router using netconf. And this is the process flow in the mitigation mode. And as before, HPin1 performs SYN flat attacks to HPin2, and the system detected the attacks in 20 seconds after the transmission started, and configured the additional filter setting for the router using netconf. But unlike monitor mode, the packet discarding setting is set for mitigation mode. In fact, after this rule was set, HPin2 stopped receiving packets from HPin1. And then, as in monitor mode, 5 minutes after HPin1 stops the SYN flat attack, the system sends the filter release configuration to the router using netconf. And this is an example of configuration sent from the system to the router in monitor mode. I'm sorry for the small font, but as this example shows, the config is set on the router when an attack is detected, and the router is and the filter is removed in 5 minutes after the attack is over. And this example is monitor mode, so accept was set like this. And here is another example for mitigation mode. The behaviors of automatically setting and unsetting configuration of the router is the same as in monitor mode, but this is the because of this is mitigation mode. So we can confirm that this card was set like here, and this card setting. And this slide shows the actual configuration of the DDoS mitigation service system being serviced. And this system inputs packets mirrored from 2 routers with the traffic reduced to 1 second, 1,000. As in the previous test environment, the system and these routers RM1, 2, 3 works together. And this is about the setting of threshold and the rate limit. And there are 2 types of parameters for each detection rule. One is the threshold and the other one is the limit. The 2 graphs below shows the threshold and the rate limit. And as shown in these graphs, if the traffic matching the condition exceeds the threshold, all such traffic is subject to blocking, and only the amount exceeding the rate limit is blocked and allowed up to rate limit even if the detection condition is met. So, and from here, I will talk about the user portal site, and the administrator of each institution can access the services portal site to view traffic volumes and attacks in real time. And information that can be found on the portal site can be found on this slide. And the user can check the graphical display of the traffic volumes and the display of the IP addresses of frequent attack targets. And the last one is the list of detected attacks. And in addition to the information display, the system also provides the email reporting function and login user management functions. And this is the user portal's overview screen. And as explained in the previous slide, the overview screen provides a traffic graph and a list of detected attacks. And as shown in the slide, users can specify the date and time or set the slider to narrow down the target to be displayed. Additionally, users can view traffic volumes graphs and ranking of the most frequently attacked IP addresses in institutions network, and also view a list of detected attacks. And then this is the analysis screen. The analysis screen by the list of detected attacks, and by clicking the plus icon from the attack list to view the traffic graph of the individual attacks. Also, users can specify conditions to narrow down the list of the attacks to be displayed. And the system can also extract and list attack information for registered IP addresses. For example, users can extract and list the attacks they have received according to the IP address attacked as in number 1, and the type of the attack as in number 2, and the protocol and the port numbers of the attack target as in number 3. And the system can be displayed with the actual group name if the administrator of each institution registers the name in advance like this. And details on the asset groups and asset names are shown on this slide, and users can subdivide and name pre-registered network addresses for group management. And this configuration allows the user to view, sort, and search the network segment to which the IP addresses of the attack target belongs by defined name in the overview screen and analysis screen. And this is the conclusion and our future tasks as conclusion. So our new DDoS mitigation service was launched as an official service in January in this year after the operational verification. And now 36 institutions are using the new service. And currently in development as a packet drop function, which will be available upon completion. And as future tasks, we are now considering a method to evaluate the attack detection accuracy of the system. But it is so difficult for us to know if the detected attacks were actually observed at each institution. So we think that we need to get feedbacks on regular user service, and we need to tuning of the attack detection threshold and their maintenance is not easy, since the line bandwidth of institutions connected to SINET range from the less than 1 gigabps to 400 gigabps. So we are now set the several threshold for each line bandwidth institution, but I think that we need to adjust while continuously checking attack detection status. Okay, that's all for my presentation. Thank you very much.
Okay, sorry, because of time constraint, if you have any other questions for Akashi-san or Kitagawa-san, maybe during the break. Okay, so thanks for sharing on SINET as well as the DDoS service. Next, we have sharing on the exploration of new journey in APAN JP. So in this sharing, there'll be 4 topics. One on the latest contribution of Starlink circuit to the data move challenge. They will also share the latest persona node update in APAN JP Tokyo. Also provide an update on the segment routing implementation, and also on the update on the Giant JP4L. So this will be presented by 3 of them: Hirotaka Sato, Kodai Motohashi, and Matien. Thanks.
Hello everyone, I'm Gemma from APAN JP Node. Today, I and Motohashi-san and Sato-san would like to talk to you about exploration and new journey in APAN JP here. This is the outline of today's presentation. So first topic is provide a Starlink to DMC23. The Data Move Challenge is a competition hosted by National Supercomputer Center Singapore once every 2 years. This year, it will be held from August 1st to October 30th for teams to showcase their solutions for transferring a large amount of data global using 100 gigabps data transfer node over the international research and education networks. In this year, a wireless communication section using Starlink has been added for the first time, and KDDI provide a Starlink section to DMC23. So what is Starlink? Starlink is a satellite broadband internet service developed and operated by SpaceX. It started in North America, Europe, and Oceania since 2020 as a beta service, and is available over 30 countries now. in October 2022, service started in Japan KDDI, and it is the first release in the Asia region. Starlink satellite positioned in low Earth orbit at an altitude of 550 kilometers, so it can achieve significantly low latency and higher transmission speed for its end user. And Starlink can provide communication to locations that are normally difficult to connect via wired communication. Because of its difficult characteristics from regular wired communications, it has a new section added to the competition this time. So after APAN-JP received a request from Singarin to provide a Starlink section, APAN-JP has sent a request to KDDI. Since Starlink is normally a commercial service, but this time it was used for competition, so we need someone who could support the installation of satellite communications. And we contact various departments within the KDDI to find a location for the Starlink antenna, and finally choose Yamaguchi Satellite Communication Center as a suitable location for this competition. So KDDI Yamaguchi Satellite Communication Center is located in Yamaguchi Prefecture and opened in 1969. It is on the western side of Japan and 770 kilometers away from Tokyo. It is one of the largest satellite communication facilities in Japan. And right side is a photo of the whole communication center. You can see it's very spacious, and there are many. There are currently 20 parabola antenna on the site, and Starlink antenna that was installed on the rooftop this time is located here. This is a picture of the Starlink antenna. We use a standard type circular antenna, unlike the square shape of the recent business antennas. The image of the connection from Yamaguchi to DMC looks like this. Yamaguchi is on the left side of the diagram, Tokyo is in the center, and overseas is on the right side. In Yamaguchi, the Starlink antenna is connected to the router with a UTP cable with via a Starlink unit, and the power is also supplied from Starlink UT. The server in Yamaguchi is connected to SpaceX via a Starlink, and then to the APAN-JP router in Tokyo via JPIX, and finally to DTN overseas via R&D network. We also added a management segment for operational use. After connecting to the Starlink, online status, operating hours, reception level, visibility can be checked via the web UI as shown in this picture. So the contest started on August 7th. We will support it during the period. If you have any question, if you have any problem, please contact us. We hope that through this competition, more people will learn about Starlink and use Starlink in the future. Thank you.
Now, next, I will share about the planning and progress of introducing segment routing to APAN-JP backbone. This is the current APAN-JP backbone configuration, and the red path through Japan, Hong Kong, Singapore, and Thailand is the main path, and other 4 passes for the backup. As you can see, the cooperation of many organizations has helped to increase redundancy. And thanks to this, there were no isolated incidents between Japan and Singapore section in the last fiscal year. However, when there is no outage on all circuits, we don't use these circuits between Japan and Singapore, except for the main path, and traffic engineering is difficult on the current backbone. So therefore, we began to implement segment routing to perform traffic engineering. At first, I explained the overview of segment routing. Segment routing is a source routing method to represent network as segments. Segments define the actions performed on the packet, and segment list was encoded by the send node in the packet. This figure shows the overview of segment routing. Packets come from C1 and R1 receive it. The send node R1 encodes the segment list into packets on demand. For example, for IGP metric traffic engineering, R1 encodes 2, 4, 6, and the packets pass through orange route. And on the other hand, for latency traffic engineering, the packet is encoded 3, 5, 6, and pass through yellow line. So the intermediate devices refer to the assigned segment and perform the action. And the node R6 decodes the packet and deliver it to CE2. This is the overview of segment routing. So we are working on the implementation of segment routing in order to enable traffic engineering easily. For example, between the Japan and Singapore section, latency is lower on the NI Japan Singapore circuit path B. This is now backup path. Because it doesn't go through Hong Kong POP, segment routing will make it possible to easily pass through path B for certain traffic which requires low latency. In addition, we can also flexibly design backup path priority. The following is a summary of the new things that can be done with segment routing. In addition to the usual IGP metrics, it enables traffic engineering based on latency and bandwidth. Source routing also enables flex route selection at the send node. Furthermore, new functions L2 VPN and L3 VPN can be realized. In terms of fault tolerance, TI-LFA enables faster automatic rerouting. Finally, this is our current progress of introducing segment routing and future plans. We have built and tested the SRMPS backbone in virtual testing environment and completed L2, L3 VPN connectivity testing over SRMP-LS. Currently, we are testing the traffic engineering such as source routing and TI-LFA operation. The future plan is to verify the network requirements and design in the production environment. After that, deploy the SRMP's backbone and migrate the traffic from the current backbone. In addition, there is a possible interconnect test with other NLAN as experiment. Okay.
So the personal service from the APAN JP. So we have the 10 gig throughput server, and we installed finally throughput test node for the 100. And we will maintain this mattress so that most of the mattress is already becoming green, and which is a good thing. And let me explain what the current status of the 100 throughput server. So road to 100 personal measurement is long way to go for us. So we have only achieved around the 30 gig so far. So the gears that we had is more powerful than the reference has. But obviously we need more tuning for this. And the other thing, I'm simply kind of in the middle of determination, is that the current persona is based on the CentOS 7, which will be end of support by the June 30, 2024, which will be next year. And it also supports the foreign distribution, like the Red Hat family and so the Debian families as well. But the like the Ubuntu 22.04 or Debian 11, it's yet to be supported. And yeah, most of us know that the Red Hat Enterprise community, Enterprise Linux community is under the shaky moment. So the source code of the that the we don't know the where Red Hat's community going to where it's going. So the but the we are planning to the go with the Ubuntu in the current status, but we will see. And the last but not least, the next step will be the makes most use of the persona, so that the as you know, the APAN GPU has lots of the backup circuits. And the one thing we are not confirmed yet that the main path is working fine, so that our traffic is already on it. And the persona going through that path. But the thing is that we never know how the backup is going on. So we are not ready for the making sure that whether the backup circuit is already all good or not. So the by using this the segment routing that he had mentioned, we could traverse the traffic to the backup path for the limited time, so that we could do more with confirming the backup path as well. So the we don't have the personal server in the we have the personal server in Tokyo, but we don't have it in the Singapore, so that we could single link can support us in terms of this experiment. So that will be the next step for us. And I was supposed to present the Giant P4 test beds in here, but since we have done too much, so I leave it for the my friend Frederick in the Giant for the next speaker. And for the summary, so we have been doing. So I was kind of wondering what I could contribute and support this community for the better science and so on. So the APAN JP has not so much money, but we have us, so that we could complete and so on. So the starting was the kind of start, so that anyone on the contest can test, and also after that we confirm that the starting can be a good thing to use it, so that more people can use it in the later coming years. And also the segment routing, so that we can select the best path, so that shorter latency, the more people will be happy about it, I think. And we are starting with the 100 persona, so that we are at the staging point, but the testing point, so that once we found out what should be done with that, so that we can explain and everything for the rest of the people in the APAN community. And we are in terms of the welcoming all the challenges that we are interested in, especially just starting what's one of the best. So thank you, and thank you for listening. So the question will be later, right?
Yeah, thanks Sado-san, Motohashi-san, and also Martin for sharing. Yeah, thanks. I think all this effort to optimize routes and performance to enable science is really important. I think the interesting thing was about the Starlink DMC. So let's see the results of it. Yep.
Yeah, I think this is one of the first time that we ever had a Starlink as part of the competition.
Yeah.
This is really done very well. I think it was it's really thanks to APAN JP and KDEI for enabling that. They actually have done a lot of work in setting it up and a lot of testing. And in fact, the participants so far have found it very challenging because of rather than high bandwidth. Now you have a constrained bandwidth. And the reason why we have the Starlink as part of the competition is we want to see what happens if there is a disaster somewhere. Can we use the Starlink to help in emergency cases? So it is very, very interesting. We are learning from the participants using it. And because we have interviews with the participants, we learn what were the challenges and how some of them have actually overcome that challenges. Although I can't say it now because some of the coming participants, we are in the midst of it, have not completed it. But so far, the 2 participants that have completed it has been really revealing a lot of things about us and how we can better use it, the Starlink in certain circumstances. Yeah, I really have to thank them. Yeah. Dennis. I think he's on the phone. Anya.
Excuse me.
Something about.
Okay.
Starlink.
So in the ASTI, besides the research network that we run, another group there is doing community networks. So around a month ago, we brought 2 terminals that we gave to the community networks group, which they deployed in Mountainous Elementary School in the Philippines. So that's basically our experience with Starlink right now, and the quality of the internet is actually good compared to what they have in the mountain right now, which is almost not usable. So yeah. The Ministry of ICT is in the Philippines is talking a lot with Starlink right now. They plan to procure a lot, and they plan to deploy it in what they call GIDA sites, geographically isolated areas in the Philippines. So this is in collaboration with the USAID in the Philippines.
Thank you for sharing. And I think this is very important because there are some of the NRENs in our community where there are some places that are difficult to get access to, and in Starlink is there, it can help. And the latency is not that bad. The latency is really not that bad. And the bandwidth, not that good, but it's not 100 gig, but it's about 20 to 40 megabits per second, which is sufficient for training, teaching, remote teaching. So for us, it's been a revealing technology to use. Thanks, Konishi-san, for letting me think. Yeah.
Actually, later we have a lightning session, right? So I don't know whether Dennis has some slides you would like to share. Not sure whether you have time also. I mean, a quick one. If not, later, I think afternoon. No worries. Okay.
Okay.
Next round. Maybe next APAN.
Next time.
Okay,
Yeah.
sure. Thanks. Good. Okay, next we have from Kaus. So he'll be sharing on the planning and development of R&E networks. So the purpose of this presentation is to discuss key areas of development and innovation in the context of participant R&E networks. So I'll let Alex Mora share more on that. Thanks.